@NCERT video welcomes you. Today we are going to start Chapter 6 Perimeter and Area. Let's start Chapter 6 Perimeter and Area. 6.1 Perimeter. Do you remember what the perimeter of a closed plane figure is? Let us refresh our understanding. The perimeter of any closed plane figure is the distance covered along its boundary when you go around it once. For a polygon, that is, a closed plane figure made up of line segments, the perimeter is simply the sum of the lengths of its all sides, that is, the total distance along its outer boundary. The perimeter of a polygon is equal to the sum of the lengths of its all sides. Let us revise the formulas for the perimeter of rectangles, squares, and triangles. Perimeter of a rectangle. Consider a rectangle ABCD whose length and width are 12 cm and 8 cm respectively. What is its perimeter? Perimeter of the rectangle is equal to sum of the lengths of its four sides is equal to AB plus BC plus CD plus DA. You can see here a rectangle is given named ABCD. In this figure, AB is equal to CD and DA is equal to BC. Perimeter will be sum of all its four sides. Perimeter is equal to AB plus BC plus AB plus BC, since CD is equal to AB and DA is equal to BC. So 2 times AB plus 2 times BC or 2 times AB plus BC. 2 into 12 cm plus 8 cm is equal to 2 into 20 cm is equal to 40 cm. Opposite sides of a rectangle are always equal. So AB is equal to CD and AD is equal to BC. You can derive a formula for perimeter of a rectangle like this. This is L, this is B, this will be L and this will be also B. Perimeter will be 2 times L, 2 times B or 2L plus 2B, or perimeter is equal to 2 into L plus B. From this example, we see that perimeter of a rectangle is equal to length plus width plus length plus width. Perimeter of a rectangle is equal to 2 into length plus width. Perimeter of a rectangle is twice the sum of its length and width. Perimeter of a square. Debojit wants to put color tape all around a square photo frame of side 1 meter as shown. What will be the length of the color tape he requires? Since Debojit wants to put the color tape all around the square photo frame, he needs to find the perimeter of the photo frame. Thus, the length of the tape required is equal to perimeter of the square. Sum of the lengths of all four sides of the square is equal to 1 meter plus 1 meter plus 1 meter plus 1 meter is equal to 4 meter. You can derive the formula here. If this side is A, this one A, this one A, and this one A2, then perimeter will be A plus A plus A plus A. That is 4 times A. That is 4 times of length of one side. Now we know that all 4 sides of a square are equal in length. Therefore, in place of adding the lengths of each side, we can simply multiply the length of one side by 4. Thus, the length of the tape required is equal to 4 into 1 meter is equal to 4 meter. From this example, we see that perimeter of a square is equal to 4 into length of a side. The perimeter of a square is quadruple the length of its side. Perimeter of a triangle. Consider a triangle having 3 given sides of lengths 4 cm, 5 cm and 7 cm. Find its perimeter. Perimeter of the triangle is equal to 4 cm plus 5 cm plus 7 cm is equal to 16 cm. If you want to derive the formula, then you can derive like this. If the sides are ABC, then perimeter is equal to A plus B plus C. That is sum of all the 3 sides. Perimeter of a triangle is equal to sum of the lengths of its 3 sides. Example. Sakshi wants to put lace all around a rectangular tablecloth that is 3 meter long and 2 meter wide. Find the length of the lace required. Solution. Length of the rectangle table cover is equal to 3 meter. Width of the rectangular table cover is equal to 2 meter. Akshi wants to put lace all around the tablecloth. Therefore, the length of the lace required will be the perimeter of the rectangular tablecloth. Now, the perimeter of the rectangular tablecloth is equal to 2 into length plus width is equal to 2 into 3 plus 2 is equal to 2 into 5 is equal to 10 meter. Hence, the length of the lace required is 10 meter. You can do like this. This is 3 meter. This is 2 meter. You know perimeter is equal to 2 into L plus P. 2 into 3 plus 2. 2 into 5, that is 10 meter. Example. Find the distance traveled by Usha if she takes 3 rounds of a square park of side 75 meter. Solution. Perimeter of the square park is equal to 4 into length of a side, that is equal to 4 into 75 meter is equal to 300 meter. Distance covered by Usha in one round is equal to 300 meter. Therefore, the total distance traveled by Usha in 3 rounds is equal to 3 times 300 is equal to 900 meter. You know, perimeter for a square is 4 times its side, that is 4 into 75 is equal to 300 meter. Since Usha takes 3 rounds, so distance traveled will be 3 times P or 3 into 300 or 900 meter. Figure it out. 1. Find the missing terms. A. Perimeter of a rectangle is equal to 14 cm. Width is equal to 2 cm. Length is equal to how much? You already know the formula here. Perimeter is equal to 2 into L plus P. Here perimeter is equal to 14 centimeter. Length is not given, but width is given, 2 centimeter. Length will be 5 centimeter. B. Perimeter of a square is equal to 20 centimeter. Side of a length is equal to dash. You know perimeter of a square is equal to 4 times its side length. Perimeter is given 20 centimeter. Side is not given. So side will be 20 divided by 4 is equal to 5 centimeter. See, perimeter of a rectangle is equal to 12 meter, length is equal to 3 meter, width is equal to dash. You already know perimeter of a rectangle is equal to 2 into L plus B. Perimeter is given here 12, length is given 3, but width is not given. The answer will be 3 meter. 2. A rectangle having side lengths 5 cm and 3 cm is made using a piece of wire. If the wire is straightened and then bent to form a square, what will be the length of a side of the square? It is given that the rectangle has been straightened and made into a square. So the length will remain the same. That means perimeter of rectangle will be perimeter of a square. Length of a side of a square will be 4 centimeter. 3. Find the length of the third side of a triangle having a perimeter of 55 centimeter and having two sides of length 20 centimeter and 14 centimeter respectively. You know that perimeter of a triangle is equal to sum of all sides, that is P is equal to A plus B plus C. It is given that one side is 20, other is 14. Let's take A is equal to 20, B is equal to 14. Then how much will be C? Perimeter is equal to 55. C will be 55 minus 34. That is 21 centimeter. 4. What will be the cost of fencing a rectangular park whose length is 150 meter and width is 120 meter if the fence cost rupees 40 per meter? Let's calculate the perimeter. Length is 150, width is 120. Then perimeter will be 2 times length plus width. Perimeter will be 540 meter. That means the length of fence required will be 540 meters. If 1 meter costs rupees 40, then 540 meter will cost 40 into 540. The answer will be 21,600 rupees. 5. A piece of string is 36 centimeter long. What will be the length of each side if it is used to form A square, B, a triangle with all sides of equal length, and C, a hexagon, a six-sided closed figure with sides of equal length. It is given the length of the string is 36 centimeter. You have to form a square, a equilateral triangle, and a regular hexagon. All sides are equal for a triangle. Then perimeter will be 3a. It is given 36 is perimeter, so side length will be 36 by 3 or 12 centimeter. This will be for the second one, that is triangle. For a square whose all sides are equal, perimeter is equal to 4a. Since length of string is 36 centimeter, side length of the square will be 9 centimeter. That will be the answer for A. For hexagon having all sides equal like this, perimeter will be 6a. A will be 36 by 6 or 6 centimeter. That will be the answer for third one. 6. A farmer has a rectangular field having length 230 meter and breadth 160 meter. He wants to fence it with 3 rounds of rope as shown. What will be the total length of rope needed? You have to find perimeter for a rectangle whose length is 230 meter and breadth is 160 meter. Since 3 rounds of rope is taken, so the answer will be 3 times perimeter. Kindly do that. Matha Bachi. Akshi and Tosi start running along the rectangular track as shown in the figure. Akshi runs along the outer track and completes 5 rounds. Tosi runs along the inner track and completes 7 rounds. Now they are wondering who ran more. Find out who ran the longer distance. You can see 2 paths, that is inner track and outer track. Inner track has dimensions 60 into 30. Outer track has dimensions 70 into 40. Tosi runs on inner track, so in one round she will cover 2 into 60 plus 30, that is 2 into 90, that is 180 meter. In 7 rounds, Tosi will cover 7 into 180, that is equal to 1260 meter. Since Akshi runs along the outer track, in one round she will cover 2 into 70 plus 40, that is 2 into 110 or 220 meter. In 5 rounds she will cover 5 into 220, that is 1100 meter. So you can see 1260 is more than 1100. So Tosi has covered more distance. Each track is a rectangle. Tosi's track has length 70 meter and width 40 meter. Running one complete round on this track would cover 220 meter. That is 2 into 70 plus 40 meter is equal to 220 meter. This is the distance covered by Akshi in one round. Similarly, distance covered by Tosi was 2 into 60 plus 30, that is 2 into 90, that is 180 meter in one round. Figure it out. 1. Find out total distance Akshi has covered in 5 rounds, that is 5 into 220, that is 1100 meter. 2. Find out the total distance Tosi has covered in 7 rounds, who ran a longer distance. In 7 rounds, Tosi will cover 7 into 180, that is equal to 1260. So, Tosi has covered a longer distance. 3. Think and mark the position as directed. A. Mark A at the point where Akshi will be after she ran 250 meter. B. Mark B at the point where Akshi will be after she ran 500 meter. C. Now Akshi ran 1000 meter. How many full rounds has she finished running around her track? Mark her position as C. D. Mark as at the point where Tosi will be after she ran 250 meter. E. Mark Y at the point where Tosi will be after she ran 500 meter. F. Now Tosi ran 1000 meter. How many full rounds has she finished running around her track? Mark her position as Z. Deep dive. In races, usually there is a common finish line for all the runners. Here are two square running tracks with the inner track of 100 meter each side and outer track of 150 meter each side. The common finish line for both runners is shown by the flags in the figure, which are in the center of one of the sides of the tracks. Common finishing line. If the total race is of 350 meter, then we have to find out where the starting position of the two runners should be on these two tracks so that they both have a common finishing line after they ran for 350 meter. Mark the starting points of the runner on the inner track as A and the runner on the outer track as B. You can see two tracks in the shape of square. Inner track has side length 100 meter and outer track has side length 150 meter. Since this is the finishing line and the race is of 350 meter, so you have to move 350 meter in backward direction to get the starting position. For inner track, here 50 meter, then 100 meter, that will be 150, then again 100 added to it 250, and again 100, 350. So for inner track the starting point will be here, so it should be marked A as said in the question. The starting point of the runner on the inner track is A. Similarly, you have to move 350 meter from the finishing point or finishing line on the outer track. Half of 150 is 75. This is 150 meter, that is 75 and 150 is equal to 225. Distance to be covered is 350 minus 225, that is 125 from this point. So the starting point for outer track will be here. This length is 125. This length is 150 meter and this one 75 meter. You can add them all. 125 first, then 150, then 75. You will get 350. So the starting point for outer track will be here, and for inner track it will be here. Estimate and verify. Take a rough sheet of paper or a sheet of newspaper. Make a few random shapes by cutting the paper in different ways. Estimate the total length of boundaries of each shape, then use scale or measuring tape to measure and verify the perimeter for each shape. Akshi says that the perimeter of this triangle shape is 9 units. Tosi says it can't be 9 units. The perimeter will be more than 9 units. What do you think? Akshi says the perimeter is 9 units. Tosi says no, it will be more than 9 units. You can see a triangle here. It has 3 sides. 2 are shown using red lines and 1 using blue lines. Along the red line, the lengths are 3 units in horizontal position, 3 units in vertical position. You can see this length, that is a part of the blue one, is longer than the red one, or you can say this part is longer than this one, so it should be more than 3. So this one 3, this one 3, and this one more than 3 will be overall more than 9. So Tosi is correct. The perimeter will be more than 9 units. This figure has lines of two different unit lengths. Measure the lengths of a red line and a blue line. Are they same? We will call the red line straight lines and blue lines diagonal lines. So the perimeter of this triangle is 6 straight units plus 3 diagonal units. We can write this in a short form as 6s plus 3d units. In the previous page you have seen this has 3 straight units and 3 straight units here, that means 6 straight units. and this has 3 diagonal units. So 3 diagonal units. So overall perimeter will be 6s plus 3d, that is 6 straight units plus 3 diagonal units, written as 6s plus 3d. Write the perimeter of the figures below in terms of straight and diagonal units. S, 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 and S and S. 8 times S, so 8S. Number of diagonal units 1 and 2. 2D. That means 6 straight units and 2 diagonal units. Similarly, for the second figure, number of straight units will be 4 and diagonal units 1, 2, 3, 4, 5, 6. Similarly, you can do for the third and fourth figure. Perimeter of a regular polygon. Like squares, closed figures that have all sides and all angles equal are called regular polygons. We studied the sequence of regular polygons as shape sequence as 1 in chapter 1. Examples of regular polygons are the equilateral triangle, where all the 3 sides and all 3 angles are equal. Regular pentagon, where all 5 sides and all 5 angles are equal, etc. Perimeter of an equilateral triangle. We know that for any triangle, its perimeter is sum of all 3 sides. Using this understanding, we can find the perimeter of an equilateral triangle. Perimeter of an equilateral triangle is equal to AB plus BC plus AC. Since all sides are equal, you can write this as AB plus AB plus AB, or 3 times length of one side. Perimeter of an equilateral triangle is equal to 3 into length of a side. What is a similarity between a square and an equilateral triangle? Since a square is a regular polygon having 4 sides, since all are equal, so perimeter will be 4 times side length. In equilateral triangle, the perimeter is 3 times side length. Similarly, for regular pentagon, perimeter is equal to 5 times side length. Similarly, for regular hexagon, whose all sides and all angles are equal, perimeter will be 6 times side length. Find various objects from your surroundings that have regular shapes and find their perimeters. Also, generalize your understanding for the perimeter of other regular polygons. Teacher's note: discuss more about regular polygons and encourage students to come up with a general formula for the perimeter of a regular polygon. Perimeter for a regular polygon is equal to number of sides into length of a side. Split and rejoin. A rectangular paper sheet of dimension 6 cm into 4 cm is cut as shown into two equal pieces. These two pieces are joined in different ways. You can see two pieces here. These can be joined in different ways like this. So perimeter of original shape is 2 into 6 plus 4, that is 2 into 10 or 20 centimeter. Perimeter of this shape will be, this is 12 centimeter and this one 2 centimeter. So 2 times 12 plus 2, that is 28 centimeter. For example, the arrangement A has a perimeter of 28 centimeter. Find out the length of the boundary, that is the perimeter of each of the other arrangements below. First, you have to write the side lengths like this. This is 2 centimeter. This is 6 centimeter. This one 6 centimeter. This one 6 centimeter. This one 2 centimeter. This one 6 minus 2, that is 4 centimeter. Sum of all sides will be how many 6? 1, 2, 3. 3 into 6 plus how many 2's? 1, 2, 3 and 1 4. That will be 28 centimeter. Similarly, for this figure, you have to write the length of outer boundary. Perimeter will be how many 6? 1, 2, 3. 3 into 6 plus how many 2's? 1, 2, 3, 4, 5. 18 plus 10 is equal to 28 centimeter. For the last figure, you have to write outer dimensions. Since this is 6 centimeter, this will be 6 minus 3, that is 3 centimeter. This one will be 3 centimeter since this one is 6 centimeter. This one 2 centimeter. So perimeter will be 2 times 6, 2 times 2 and 2 times 3. 22 centimeter. Arrange the two pieces to form a figure with a perimeter of 22 centimeter. Kindly try to do that. 6.2 Area. We have studied the area of closed figures, regular and irregular, in previous grades. Let us recall some key points. The amount of region enclosed by a closed figure is called its area. In previous grades, we arrived at the formula for the area of a rectangle and a square using square grid paper. Do you remember? If this is a rectangle with length L and width W, area will be length into width. Sometimes width is written as width or B. For area of a square, if this is side S, sometimes it's written as A, the area will be length into length or S into S or S square. So area of a square is equal to length into length. Area of a rectangle is length into width. L into W or L into L, sometimes said as S into S. S for street units. Teacher's note: help students in recalling the method of finding the area of a rectangle and a square using grid papers. Provide square grid papers to students and let them come up with the formula. Let us see some real life problems related to these ideas. Example: a floor is 5 meter long and 4 meter wide. A square carpet of sides 3 meter is laid on the floor. Find the area of the floor that is not carpeted. Solution: length of the floor 5 meter, width of the floor 4 meter, area of the floor length into width 5 meter into 4 meter, that is 20 square meter. Length of the square carpet is equal to 3 meter. Area of the carpet is equal to length into length 3 meter into 3 meter, 9 square meter. Hence the area of the floor laid with carpet is 9 square meter. Therefore the area of the floor that is not carpeted is area of the floor minus the area of the floor laid with carpet, that is 20 square meter minus 9 square meter is equal to 11 square meter. Area of the floor is 5 into 4, that is 5 into 4 length into width, and area of the carpet, that is in a square shape, 3 into 3, that is length into length. So area left will be 20 minus 9, that is 11 square meter. Example: 4 square flower beds, each of side 4 meter, are in 4 corners on a piece of land 12 meter long and 10 meter wide. Find the area of the remaining part of the land. Since the piece of land has dimensions 12 meter and 10 meter, its area will be 12 into 10, that is 120 square meter. Since 4 corners has 4 square beds of flower, it is said 4 square flower beds each of side 4 meter. So area of a square flower bed will be 4 into 4, that is 16 square meter. Since there are 4 square bed, total area will be 4 into 16 square meter, that is 64 square meter. So area left will be area of land minus total area of flower bed, that is 120 minus 64 square meter, that is 56 square meter. The answer is 56 square meter. Solution: length of the land L is equal to 12 meter, Width of the land is equal to 10 meter. Area of the whole land L into W, that is 12 into 10 meter, that is 120 square meter. The side length of each of the 4 square flower beds is 4 meter. Area of one flower bed is equal to S into S, 4 into 4 is equal to 16 square meter. Hence the area of the 4 flower bed is equal to 4 into 16 square meter, that is 64 square meter. Therefore, the area of the remaining part of the land is area of the complete land minus the area of all 4 flower beds, that is 120 square meter minus 64 square meter is equal to 56 square meter. Figure it out. 1. The area of a rectangular garden 25 meter long is 300 square meter. What is the width of the garden? You know, area is equal to length into width. Area is 300 square meter. Length is 25 meter. Then width will be 300 divided by 25. The answer is 12 meter. The width will be 12 meter. 2. What is the cost of tilling a rectangular plot of land 500 meter long and 200 meter wide at the rate of rupees 8 per 100 square meter? The area will be length into width. Length is 500 meter and width is 200 meter. That is 1 lakh square meter. Since for tilling 100 square meter of land cost rupees 8, then for tilling 1 square meter of land will cost 8 divided by 100 rupees. For 1 lakh square meter of land, the cost will be 8 divided by 100 into 1 lakh. The answer is 8,000 rupees. 3. A rectangular coconut grove is 100 meter long and 50 meter wide. If each coconut tree requires 25 square meter, what is the maximum number of trees that can be planted in this grove? Area of the plot is 100 into 50, that is length into width, that is 5000 square meter. Since 25 square meter is required for one coconut tree, so in 1 square meter will have 1 by 25 portion of a coconut tree. So a land having 5000 square meter area will have 1 by 25 into 5000 coconuts tree, that is 200 coconuts tree. 4. By splitting the following figures into rectangles, find their areas. All measures are given in meters. You can split the given figure in rectangles and find the area. This rectangle will have area, that is 4 into 3. This rectangle will have area 4 into 1. This rectangle will have area 3 into 2. And this one 3 into 2. So the total area will be sum of area of all four rectangles. That is 28 square meter. For the second figure, the area of this rectangle will be this one, 2 meter. That is 2 into 1. Similarly, for this one, 2 into 1. Since this length is 5 meter and this one is 1 meter, the area will be 5 into 1. The answer is 2 plus 2 plus 5 or 9 square meter. Figure it out. Cut out the 10-gram pieces given at the end of your textbook. 1. Explore and figure out how many pieces have the same area. 2. How many times bigger is shape D as compared to shape C? What is the relationship between shapes C, D and E? 3. Which shape has more area, shape D or F? Give reasons for your answer. 4. Which shape has more area, shape F or G? Give reasons for your answer. 5. What is the area of shape A as compared to shape G? Is it twice as big, 4 times as big? Hint: in the 10-gram pieces, by placing the shapes over each other, we can find out that shape A and B have the same area, shape C and E have the same area. You would have also figured out that shape D can be exactly covered using shape C and E, which means shape D has twice the area of shape C or shape E, etc. 6. Can you now figure out the area of the big square formed with all 7 pieces in terms of the area of shape C? 7. Arrange these 7 pieces to form a rectangle. What will be the area of this rectangle in terms of the area of shape C now? Give reasons for your answer. 8. Are the perimeters of the square and the rectangle formed from these 7 pieces different or the same? Give an explanation for your answer. Look at the figures below and guess which one of them has a larger area. A, B. We can estimate the area of any simple closed shape by using a sheet of squared paper or graph paper where every square measures 1 unit into 1 unit or 1 square unit. To estimate the area, we can trace the shape onto a piece of transparent paper and place the same on a piece of squared or graph paper and then follow the below conventions. 1. The area of one full small square of the squared or graph paper is taken as 1 square unit. 2. Ignore portions of the area that are less than half a square. 3. If more than half of a square is in a region, just count it as 1 square unit. 4. If exactly half the square is counted, take its area as half square unit. Find out the area of the following figures. Exactly half, exactly half. So 2 halves, and 3 complete square units. That is 1 plus 3, the answer is 4 square unit. The area is 4 square unit. Similarly, for the second figure, 1 half, 2 half, 3 half, 4 half, 5 half, and 6 half. That is 6 into 1 by 2. And number of complete squares 1, 2, 3, 4, 5, 6 plus 6. The answer is 9 square unit. For third figure, number of halves 1, 2, 3, 4, 5, 6. That is 6 into 1 by 2. And complete squares 1, 2, 3, 4, 5, 6, 7. The area is 10 square unit. Similarly, you can do for this figure. Please note that 1 complete means 1 square unit, half means half square unit. It should be exactly half. If it is more than half, like this or like this, it should be taken as 1 square unit. If it is less than half units, like this, then it should be taken 0 square units. This has been mentioned here. Let's explore why is the area generally measured using squares. Draw a circle on a graph sheet with diameter width of length 3. Count the squares and use them to estimate the area of the circular region. This girl says, why can't we use circles instead of squares to find the area? As you can see, circles can't be packed tightly without gaps in between. As you can see, circles can't be packed tightly without gaps in between. So, it is difficult to get an accurate measurement of area using circles as units. Here, the same rectangle is packed in two different ways. With circles, the first one has 42 circles and the second one has 44 circles. You can see gaps here. And in the second one, you can see gaps here. They are not tightly packed. So we use squares to find the area. Try using different shapes, triangle and rectangle, to fill the given space without overlaps and gaps, and find out the merits associated with using a square shape to find the area rather than another shape. List out the points that make a square the best shape to use to measure area. 1. Find the area in square meters of the floor outside the corridor. 2. Find the area in square meters occupied by your school playground. Let's explore. On a squared grid paper, 1 square is equal to 1 square unit. Make as many rectangles as you can whose lengths and widths are a whole number of units such that the area of the rectangle is 24 square units. A. Which rectangle has the greater perimeter? B. Which rectangle has the least perimeter? 24 can be written as 24 into 1. The length can be 24 and width can be 1. Similarly, it can be written as 12 into 2 or 8 into 3 or 6 into 4. Let's see perimeter in each case. In the first case, perimeter will be 2 into 24 plus 1, that is 2 into 25, that is 50 units. In second case, perimeter is 2 into 12 plus 2, that is 2 into 14, that is 28 units. In third case, perimeter is 2 into 8 plus 3, that is 2 into 11, that is 22 units. In the fourth case, perimeter is 2 into 6 plus 4, that is 2 into 10, that is 20 units. You can see here that when the difference between length and width is maximum, you get maximum or greatest perimeter, that is length 24 and width 1 unit. And for the last case, when the difference between length and width is minimum, you get least perimeter, that is length 6 units and width 4 units. See, if you take a rectangle of area 32 square centimeter, what will your answers be? Given any area, is it possible to predict the shape of the rectangle with the greatest perimeter as well as the least perimeter? Give examples and reasons for your answers. Kindly try to do that. 6.3 Area of a triangle. Draw a rectangle on a piece of paper and draw one of its diagonals. Cut the rectangle along that diagonal and get two triangles. Check whether the two triangles overlap each other exactly. Do they have the same area? Like this. This triangle has same area as that of this one. Try this with more rectangles having different dimensions. You can check this for a square as well. Can you draw any inferences from this exercise? Please write it here. Now see the figures below. Is the area of the blue rectangle more or less than the area of the yellow triangle? Or is it the same? Why? Yes, it is the same. This is the half and this is the another half. Half and half makes a complete rectangle. Can you see more relationships between the blue rectangle and the yellow triangle and their areas? Write the relationship here. Yes, area of this portion of the triangle, that is half of the rectangle, that is half into length into width, that is half of area of rectangle. Teacher's note: help students in articulating their inferences and in defining the relationships they have observed in their own words, gradually leading to a common statement for whole classroom. Recall the definition of a diagonal in the classroom. Draw suitable triangles on grid paper to verify your inferences and relationships observed in the above exercises. Use your understanding from previous grades to calculate the area of any closed figure using grid paper, and 1. Find the area of blue triangle BED. You can see a blue triangle here, triangle BAD. BAD. As we have already observed that this is the half of the area of the rectangle ABCD, the bigger one. Half of area of rectangle ABCD. Similarly, find the area of red triangle ABE. Area of red triangle ABE. ABE. That is this one. You can see it has two portions. One half here and the other half here. That is, one half is half of green rectangle and the other half is half of yellow rectangle. So you can say area of this triangle is half of area of rectangle AFED, that is green one, and area of this portion is half of area of rectangle FBCE. Since rectangle AFED and rectangle FBCE, that is green one and yellow one, makes the complete rectangle, that is ABCD. You can write this is equal to half of area of rectangle ABCD. So the area of red triangle will be half of area of the rectangle ABCD. In this way, you can say area of blue triangle is equal to area of red triangle. That is, area of triangle BAD is equal to area of triangle ABE. Both the red and blue triangles have the same area, but they look very different. Area of rectangle ABCD is equal to AB into BC. That is, product of length into width. Or you can say 1, 2, 3, 4, 5, 5 units length, 1, 2, 3, 4, 4 units width. That is 20 square units. So the area of triangle BAD is half of the area of rectangle ABCD, that is 10 square units. What about triangle ABE? There are two halves of two different rectangles. Area of triangle ABE is equal to area of triangle AEF plus area of triangle BEF. Here, the area of triangle AEF is equal to half of area of rectangle AFED, that is green rectangle. Similarly, the area of triangle BEF is equal to half of area of rectangle BFEC, that is yellow rectangle. Thus, area of triangle ABE is equal to half of area of rectangle AFED plus half of area of rectangle BFEC, that is green rectangle and yellow rectangle. Since they both make a complete rectangle ABCD, you can say half of sum of areas of rectangles AFED and rectangle BFEC is equal to half of area of rectangle ABCD. You can write your conclusions here. Figure it out. 1. Find the areas of figures below by dividing them into rectangles and triangles. You can see here, this is half of a rectangle, that is 1, 2, 3, 4. That is 4 square units. That means this is 2 square units. Similarly, this one is half of a rectangle, that is this one. You can see here, this is a rectangle having area 4 square units, and the red one is half of 4, that is 2 square units. Similarly, this non-colored rectangle, that is this one, has length 5 and width 4, that is 5 into 4, 20 square units. Adding all these, you will get 24 square units. Area of this figure is 24 square units. Similarly, in second picture, area of this triangle is half of area of this rectangle. 1, 2, 3, 4. 1, 2, 3. 4 into 3, that is half of 4 into 3, that is half of 12, that is 6. 6 square units. Similarly, this triangle is half of this blue rectangle. So the area will be half of 1, 2, 3, 4, 5, 6, 7, 8. 8. That is 4 square units. Similarly, this rectangle having length 1, 2, 3, 4, 5 and width 1, 2, 3, 4. 5 into 4, that is 20. Adding all these three, you will get 30 square units. Similarly, you can split the given figures into triangles and rectangles and find the area. Making it more or less. Observe these two figures. Is there any similarity or difference between the two? This is a square having side length 3. This is modified version of this square. If you place this here and this one here, you will get the same square. Using 9 unit squares having an area of 9 square units, we have made figures with two different perimeters. The first figure has a perimeter of 12 units and the second has a perimeter of 20 units. Let's count. 3, 3, 6, 3, 9 and 3, 12. First one has perimeter of 12 units and the second one 4, 4, 8, 3, 11, 3, 14, 15, 16, 17, 18, 19, 20. Second has a perimeter of 20 units. Arrange or draw different figures with 9 square units to get other perimeters. Each square should align with at least one other square on at least one side completely, and together all squares should form a single connected figure with no holes, like this. Using 9 unit squares, solve the following. 1. What is the smallest perimeter possible? 2. What is the largest perimeter possible? 3. Make a figure with a perimeter of 18 units. 4. Can you make other shaped figures for each of the above 3 perimeters, or is there only one shape with that perimeter? What is your reasoning? Let us do something tricky now. We have a figure below having perimeter 24 units. Without calculating all over again, observe thing and find out what will be the change in the perimeter if a new square is attached as shown on the right. If this square is added, what will happen? It will depend. If the square is added here, the perimeter will increase by 2 units. If it is added here, the perimeter will decrease by 2 units. Similarly, if the square is added here, there will be no increase or decrease in the perimeter. Kindly do that and check. Experiment placing this new square at different places and think what the change in perimeter will be. Can you place the square so that the perimeter increases, decreases, stays the same? Below is the house plan of Charan. It is a rectangular plot. Look at the plan. What do you notice? You can see master bedroom 15 feet into 15 feet, area 225 square feet, toilet 5 feet into 10 feet, utility dash feet into dash feet, area dash, kitchen 15 feet into 12 feet, area 180 square feet, small bedroom 15 feet into dash feet, area 180 square feet, hall area dash, garden dash into dash, area dash, parking dash into dash, area dash. You can see one of the side of the rectangular plot is 30 feet. You have to find the missing numbers and find the area of the whole plot. Here given, some of the measurements are given. A. Find the missing measurements. B. Find out the area of his house. Since this one is 15 feet and this one 12 feet, that means this side 12, this one 3, this one 15, and this one 5 feet, this one 15 feet. So the length will be 35 feet. So the area of the plot will be 35 into 30. That is 35 length into 30 feet width. That is area is 1050 square feet. Similarly, you have to fill here 12 so that 15 into 12 becomes 180. Since this one is 15 feet, so this will be 12 feet. Since this one is 15 feet, so 15 and 12, 27 and 3, 30. Similarly, this length is 5 feet. So the length will be 20 feet and width will be 3 feet. Area will be 60 square feet. Similarly, this one will be 15 feet. 15 plus 5, 20. 35 minus 20 is equal to 15 feet. And the width is 3. 15 into 3, that is 45 square feet. To find the area of the hall, you have to split it into two parts. Since this is 10 feet, that means this will be 20 feet. Sorry, 20 minus 3, 17 feet. And width is 5 feet. So area will be 85 square feet here. Similarly, this length is 3 feet and 12 feet, 15 feet. And here 3 feet. So here will be 12 feet. And this length is 15 feet. So the area of this one will be 15 into 12, that is 180 square feet. Total area of the hall will be 180 plus 85 square feet, that is 265 square feet. Now find out the missing dimensions and area of Saran's home. Below is the plan. 42 feet length and width will be 15 feet plus 10 feet, that is 25 feet. Area will be 42 into 25. Area will be 1050 square feet. Find out the area of his house, that is 1050 square feet. Some of the measurements are given. A. Find the missing measurements. B. Find out the area of his house. What are the dimensions of all the different rooms in Saran's house? Compare the area and perimeters of Saran's house and Charan's house. Since this one is the utility, its area is 70 square feet, its length is 10 and width will be 7. Similarly, entrance, its width will be 7 and length will be 25 minus 10, that is 15. Area will be 105 square feet. Similarly, this one is 7. This one is 18. Both will make 25. And this one is 12. That is, together they make 37. So this will be 5 feet. So toilet will be 10 feet into 5 feet. Area is 50 square feet. Similarly, the hall will have the length of 18 plus 5, 23 feet. And width, that is width of entrance, that is 15 feet. 23 into 15. The area will be 345 square feet. Similarly, here will be 120 square feet. A small bedroom will have area of 120 square feet. You can see master bedroom here, kitchen here, utility here, entrance here, hall here, toilet here, like that. You have to compare the area and perimeter of Saran's and Charan's house. Kindly try to do that. Area maze puzzle. In each figure, find the missing value of either the length of a side or the area of a region. A. You can see this portion is double of this one. So this portion will be double of 15, that is 30 square centimeter. B. Similarly, you can find area of this shaded region. This is 3 centimeter. It is written this has area of 10 square centimeter and it is given here 3 and here 2. So this will be 2 centimeter such that this length become 5 centimeter. So 5 into 2 is equal to 10 square centimeter. Since this has width of 2 centimeter and its area is 10 square centimeter, its length will be 5 centimeter. Since this length is 2 centimeter less than 5 centimeter, so it will be 3 centimeter. So area of this shaded region will be length into width. Since both are same, it is a square. Its area will be 3 into 3, that is 9 square centimeter. Similarly, you can do C and D. Figure it out. 1. Give the dimension of a rectangle whose area is the sum of the areas of two rectangles having measurements 5 meter into 10 meter and 2 meter into 7 meter. Area will be sum of area of the two rectangles, that is 5 meter into 10 meter, that is 50 square meter, and 2 into 7 square meter, that is 14 square meter. The area will be 64 square meter. Its dimension could be different. Its dimension can be 64 length and 1 meter width, 32 meter length, 2 meter width, and 16 length and 4 meter width. There could be different lengths and width for a rectangle whose area is 64 square meter. 2. The area of a rectangular garden that is 50 meter long is 1000 square meter. Find the width of the garden. You know, area of a rectangle is length into width. Since area is 1000 square meter and its length is 50 meter, so its width will be 1000 divided by 50 meter, that is 20 meter. 3. The floor of a room is 5 meter long and 4 meter wide. A square carpet whose sides are 3 meter in length is laid on the floor. Find the area that is not captured. You have to subtract the area of the carpet from the area of the floor of the room. The answer is area of the room minus area of the carpet. That is 20 minus 9, that is 11 square meter. 4. 4 flower beds having sides 2 meter long and 1 meter wide are dug at the four corners of a garden that is 15 meter long and 12 meter wide. How much area is not available for laying down a lawn? You have to subtract area of 4 flower beds from the area of the garden. Area of the garden is 15 into 12, that is length into width. Since there are 4 flower beds having dimensions 2 meter by 1 meter, its area will be 2 into 1 multiplied by 4. The answer is 172 square meter. 5. Shape A has an area of 18 square units and shape B has an area of 20 square units. Shape A has a longer perimeter than shape B. Draw two such shapes satisfying the given conditions. We already know that if the difference between length and width is more, then we get larger perimeter. The first shape has area of 18 square units and the second shape has area of 20 square units. The probable sizes could be for first shape 18 into 1, 9 into 2 and 6 into 3. And probable length and width for second shape with area 20 square units can be 20 into 1, that is 20 length and 1 width, 10 into 2, 5 into 4. Perimeter, if length and width is 18 and 1, that is 18 plus 1 into 2. 18 plus 1 is 19 into 2, 38. Similarly, for the second case, perimeter will be 9 plus 2 into 2. 9 plus 2, 11 into 2, that is 22. For the third case, perimeter will be 6 plus 3 into 2, that is 6 plus 3, 9 into 2, 18. Similarly, perimeter when length is 20 and width is 1, 20 plus 1, that is 21 into 2. 42. 10 plus 2 into 2, that is 24. 5 plus 4, 9 into 2, that is 18. Since in question it says, shape A has longer perimeter than shape B. For this case, you can take this and this, that is, for shape B, you can take length 10, width 2, such that perimeter will be 24. And for the shape A, the length 18 and width 1, such that perimeter is 38. And the second case, since question asks, draw two such shapes satisfying the given conditions. The second case could be, you can take length 5, width 4, such that perimeter is 18 for shape B. And for this, when compared to shape A with length 9, width 2, perimeter 22, you can see in these two cases, perimeter of shape A is more than perimeter of shape B, though area of shape B is more. 6. On a page in your book, draw a rectangular border that is 1 cm from the top and bottom and 1.5 cm from the left and right sides. What is the perimeter of the border? You can try doing that. 7. Draw a rectangle of size 12 units into 8 units. Draw another rectangle inside it. Without touching the outer rectangle that occupies exactly half the area. Area of this rectangle will be 12 into 8, that is length into width, 96. Area of the second rectangle will be half of this area, that is half of 96, that is 48 square units. Provable length and width for rectangle having area 48 square units. 48 into 1, 24 into 2, 12 into 4, and 8 into 6. Since the bigger rectangle has dimensions 12 and 8, you can't make a rectangle without touching its boundary with dimensions 48 into 1, 24 into 2, 12 into 4, as it will cross or touch the original rectangle having dimension 12 units into 8 units. So the answer will be 8 into 6. So the inner rectangle should have dimensions 8 and 6, that is length 8 and width 6, such that it doesn't touch the outer rectangle and has the area half of the area of original rectangle. 8. A square piece of paper is folded in half. The square is then cut into two rectangles along the fold. Regardless of the size of the square, one of the following statement is always true. Which statement is true here? A. Area of each rectangle is larger than the area of the square. B. The perimeter of the square is greater than the perimeter of both the rectangles added together. C. The perimeters of both the rectangles added together is always 1 whole 1 by 2 times the perimeter of the square. D. The area of the square is always 3 times as large as the areas of both rectangles added together. Summary. The perimeter of a polygon is the sum of the lengths of all its sides. A. The perimeter of a rectangle is twice the sum of its length and width. B. The perimeter of a square is 4 times the length of any one of its sides. The area of a closed figure is the measure of the region enclosed by the figure. Area is generally measured in square units. The area of a rectangle is its length times its width. The area of a square is the length of any one of its sides multiplied by itself. Two closed figures can have the same area with different perimeters or the same perimeter with different areas. Areas of regions can be estimated or even determined exactly by breaking up such regions into unit squares or into more general shaped rectangles and triangles whose areas can be calculated. For more videos, you can subscribe NCERT video. Thank you.